Hello everyone. Welcome to the course Blockchain and its Applications. So this is week one live session. I am Sai Venkatakrishnan, a PhD scholar from the Department of Computer Science and Engineering at IIT Madras. So throughout the next the remaining weeks of the course, every week at this time slot 6 to 8 p.m. Every Saturday, we'll be having this live session. So the agenda or the goal of these live sessions is to ensure that learners are in sync with whatever contents are being taught online in that week's lecture. And if you have any doubts or queries, you can there is a discussion forum for you to post your queries. But usually, having a live session would be much more helpful to the learner. So that's why these live sessions are being conducted. So I suggest you make best use of those and ask whatever doubts you have. And some of the doubts I may not be able to answer immediately, but I promise you that I'll search and I will post the answers on the discussion forum for the doubts which I'm not able to answer then and there, right? So, right. So the agenda of these live sessions would be, so for the first week, since your first week assignment deadline is set to be over, we won't be discussing week one assignment. So in the next week onwards, we'll be discussing the previous week's assignment questions and the solutions. But for this week, it will just be sort of an interactive session. If you have any doubts, you can raise your hands and I can call out your names and clarify the doubts one by one. Or if you want me to explain any concept again which you didn't understand properly in the class in the week's lecture, I can re-explain it again. Okay, so Samiksha, you have raised your hand. Any queries you have? Samiksha, do you have any query?
Sir, Shubham Chauhan, can I ask?
Yeah, sure. Go ahead.
What is the process of examinations for the blockchain and applications of NPTEL?
It will be mostly an online exam, as in you should go to a center and write. Uh, that
Sir,
will,
it is subjective based or a objective based exam?
no, um, no, I'm not sure. I'll discuss with the course instructor. So towards the last couple of weeks only, we'll get to know how the questions will be prepared. So as of now, it's not yet decided. It
So can you provide the format of examinations, that how many marks are required to get passed in the examinations or
It's
get
available on the NPTEL website, I guess. So there is nothing like pass or fail. It's just you will be given certificates, and I'm not sure whether there's a pass or fail category. You will be given certificates, and if you come above like 90 or something, you will be given like that gold certificate, and otherwise, if you be like one of the toppers, then you will be given a topper certificate like that. Right. So usually your assignments as well as the final exam, all these would be combined, aggregated and combined to give like an overall score. So that will be your final score. So if you are serious in getting a certificate, you should complete all your assignments before the deadline. And the questions. It mostly won't be subjective, it will be objective or something like that, but you can expect questions similar to the ones that you do in your assignments, right? Similar type of questions.
Sir, it is compulsory to join meeting every Saturday.
No, no, it's optional. So if you don't have any queries or something, or if you are not able to attend the live meeting, so these meetings would be recorded and they would be posted on YouTube playlist, and that playlist link would be um, shared with you on the by the NPTEL team.
Thank you, sir.
Okay, right. Um, okay, so Gaurav Mishra, you have raised your hand. Do you have any query?
Good evening, sir.
Yeah, good evening.
So I have confusion between two terms, sir.
Right,
Collision free and collision resistance
right.
to
Okay.
control. Yes, sir.
So, okay. So basically, the collision free and collision resistance are with respect to hash functions,
Yeah.
right? And there are many hash functions. So first of all, what's the hash function? We should understand properly, right? So hash
Mhm.
function is sort of like a mathematical function. It's just assume it as a black box, right? You,
Mhm.
for example, so in the messages, someone is asking SHA-256 explanation. So as part of this lecture, as far as this lecture is concerned, we need not delve into the mathematical details of the internals of SHA-256. So that's not required for this course. So that would require like a bit of mathematical maturity, and that's not required. So we should understand the why we are using a hash function, and what are the inputs and outputs, how inputs and outputs, and what are the possible security flaws that might be there, and how do we protect against those, like a high level overview. So if we understand these three things alone, it will be good enough to have a good head start into the blockchain techniques. So first of all, why do we need a hash function? What is its purpose? So the main purpose of a hash function is to ensure integrity of the data, right? For example, if I have say like like a video file of like 16 GB or something, right? What I should do is I provide this entire file to this hash function SHA-256, right? It will contain multiple operations within it. For example, like bitwise XOR, and like it will like jumble up all the bits, do some XOR, do some deterministic calculation computation on this entire video file, and finally what it will output is it will output a 256 bit
Bit hexa string.
bit output. So
Mhm.
irrespective of the size of the file, the input, whatever it's given, whether it's 16 GB or whether it's 1 byte or 16 bytes or even 1 terabyte, the output of this SHA-256 will always be a constant 256 bit output. Okay, and
Yes.
now with this 256 bit output, what will we achieve finally? That's the question, right? So the main goal of SHA-256 is, with this output we should be able to prove the integrity of the video file, right? So basically integrity means no one has tampered with this. So no one should have tampered with this video file. If anyone has tampered with this video file, say if I just changed the 28th minute of that video file frame with something else, right? Then
Mhm.
if I pass the tampered file, say if I'm passing the tampered file to the um, SHA-256 thing, right? It will give
Mhm.
an entirely different output. So this should be the way the SHA-256, the hash function basically works. So even a 1 bit change in input will change the entire output. Okay, so by this what we achieve is, if someone has tampered with the file, when you do the hash on that file again, you will get a different output, and when you compare it with the original output of the output, expected output, it will vary a lot, and you will easily get to know that someone has tampered with the file, right? So this is how SHA-256 is designed. So to design such a mathematical function, right, like a combination of XOR and all these mathematical operations, there are some properties this hash function should satisfy. So the first property is the hash function should be basically a one-way function, right? Say for example, like um, one use of the hash function is if you in your password checking everything, right? So usually what they will do is say you have a web server, right? And you as a client, you are opening a browser, some email, and you are trying to log into the web server. You provide your username and then the password, right? The web server won't be just storing the password in plain text format, right? They won't be just storing the password, say Sai123 or something. They would just be storing it in plain text, nor they will be storing it in, say, some encrypted text, encrypted format or something. Instead, what they will do is they will use a hash function to hash this password and store the hash of this in the database. Now, when I pass the username and password, right, associate the hash associated with this username will be present in this database. So what they will do is they will hash this password and compare it with the hash they have it in the database, and if it's equal to, then it's the same user, right? The authentication is successful, and they will the login is successful. So in this uh, uh, application of the hash function, right, the key
Yes.
property is the attacker should not be able to given, say, they won't be like encrypting this database, or they won't be storing these hashes secretly. So it will be open to everyone. So basically anyone can see. So if anyone can see these hashes, right, say my password is I123, and the hash provide generated is, say, 0x dead, dead, right? So in that case, um, if the attacker is able to generate a function such that I can find an inverse of this hash function, so h inverse, and if I provide this 0x dead, then the output will be the original input whatever I provided, which is I123. So if the attacker is able to find such a inverse function, providing the hash and getting the original input, right, then it defeats the whole idea of this application, because now the attacker will get to know my password, right, and he'll be able to log in successfully, and no one will be able to detect whether it's me or the attacker trying to log into the system.
Right.
So the primary goal of the hash function is to be one way. That is, it should be designed in such a way that we cannot um, um, we cannot be able to find the input given the output. So that is basically a one-way function,
Right.
and this property is known as pre-image resistant,
Okay.
right? So this is one. The second property of the hash function is, as we had discussed before, even one bit change in input should change the entire output, multiple bits in the output, right? So this is the second feature. Now the next two features are like the important ones, right?
Mm.
So one is so basically they are grouped under what is called as collision resistant.
Okay.
Okay. So basically in collision resistant, there are actually two types of collision resistant. One is weak and one is strong. Okay. So when do we call a hash function a weak collision resistant is, say for example, you have written a letter to someone, you have submitted some income tax audit, right? IT audit you have submitted, and it contains some numbers like that. Okay, and the hash of this is 0x, just 0x dead, again assume it to be same, right? And let's so this is audit 1, assume it to be. Now the attacker knows this is the hash function, okay, and if the attacker is somehow able to understand how the hash function works and is able to say somehow tweak the contents of this report in such a way that it generates a new report, IT audit 2. So for example, the report will have its own structure and organization, right? The header, the footer, and all those things. So following that same template, but somehow the attacker is able to generate a second audit report which
Okay.
makes sense. But say, for example, now instead of having the credited amount or debited amount as 1 lakh, he changes it to 10 crores or something like that. And for example, he changes other characters in the letter also. So for example, he can just add extra spaces in between. It don't change the meaning of a paragraph, but adding extra spaces will change the hash value. So somehow the attacker is able to generate a second audit report which makes sense, which is semantically correct when some human is reading it, and the hash of this second report is also 0x dead. Okay, so if this is happening, if this occurs, then we tell the hash function is not weakly collision resistant. So basically the idea is, if the attacker knows the IT audit report 1, he knows the audit report 1 and he knows the hash output. Now the goal of the attacker should be able to come up with this audit report 2 which has the same hash function. If he's not able to come up with this audit report 2, then we term the hash function as weakly collision resistant. Now what's the how can it be like, so we mentioned it to be one way, and you might have a thought that uh, if both the inputs lead to the same hash output, then won't there be a chance of corruption or something like that, right? So this is what is called as collision in hash function. So the way the hash function itself works, right? If you look at the domain of the hash function, the possible input size of these hash functions, it is basically anything, any size. It can be 1 TB or 16 GB, anything. So any number of inputs can be there, infinite number of inputs. But the output set, if you just see, it is just 256 bits. So 2 power 256 possible outputs are only possible. So the input range is significantly larger than the output range. So definitely there will be a collision between, so when we like two inputs will definitely have the same hash output, but usually the what this property suggests, weakly collision resistance suggests this, without doing a brute force attack, with just analyzing the hash function, if the attacker is able to find a second input such that it matches the same hash output of another input, then the hash function is said to be not weakly collision resistant. Okay, so brute force attack is like you just loop through all the possible inputs one by one, right? So basically you can loop through all 2 power 256 inputs, right? It will lead to a different output anyway, and you will get a hash output matching the input that you want. But a brute force attack will be time consuming and also computationally expensive. So usually when we talk of collision resistant, they focus on the mathematical properties of this hash function and how it is designed in such a way that apart from brute force, any other attack should not be possible on these hash functions. So that is what we mean by collision resistant. And weakly collision resistant is basically given the input and hash output, we should not be able to find another input such that it matches the same hash output. That is weakly collision resistant. Now, if we come to strongly collision resistant, right? In the weakly collision resistant, we had a constraint that the input is sort of fixed,
Hmm.
right? But in strongly collision resistant, it sort of makes expects the hash function to be more secure, such that the attacker should not be able to find any two inputs, say input 1 or input 2, any inputs of his own choice, both having the same hash output. So this is strongly collision resistant. So basically this means if a hash function is strongly collision resistant, it is more secure, right? And why does this matter, strongly collision resistant or weakly collision resistant is the way these for example, before SHA-256 came, right, there was another popular hash function called MD5. So this MD5 output, I guess, was 2 power, sorry, was I guess 32-bit or like 128-bit, something like that. So 64-bit or something like that. I don't remember exactly. So what happened is MD5, like at the time MD5 was introduced, it was a good hash function. But later, when the computational power became less expensive, it became cheap, right? With in the 2010s and all those in that time period, brute force was possible. A brute force approach was possible, and they were able to easily find out two sets of inputs having the same hash output, another set of input having the same hash output. So a brute force became very cheap with respect to MD5, right?
Okay.
And basically the brute force, the number of iterations that would require on average to break a hash algorithm will depend on the size of this hash output. So if say if it's a SHA-256 algorithm, the size of the number of brute force iterations um, for an attacker on average to find the input which is colliding with the another input having the same hash output will be around like 2 power 128 iterations or more than that, right? Or 2 power 256 minus 1. So it depends on whether they want to achieve strong collision resistant or weak collision resistant, right? So the hash output plays a key role in determining the strength of the hash function and how it protects itself against brute force attacks. So that's why everyone had to move from MD5 to SHA-256. Okay, so this is basically the concept of collision resistant.
Okay.
Now, is there a hash function? So what is like a perfect hash function, right? Like a perfect, for example, you would have known, right? Like a nuclear fusion reactor means it's like a perfect engine where it does not emit any pollution, it's self-sustaining, right? So in a similar way, what's a perfect hash function? A perfect hash function will no two inputs should collide at all.
Right.
So basically what it means is it's collision free. So this sort of like it's not entire, I'm not sure whether it has like a practical collision free hash function, but mathematically there are some like models or something like that which basically try to achieve collision free hash functions, but they are not implemented practically or deployed practically in real world systems. So in real world hash functions, whatever it's being deployed, collisions will occur. How far they are resistant to this collision matters. It depends on the output size, how they have designed the internals of the hash function and all those things.
Okay.
So,
Actually, sir, in the lecture, one of the property was collision free for the hash function. So
right.
I
So,
was
yeah.
confused.
So the goal of hash function is to be collision free, but that cannot be achieved in its entirety. So they try to do it like collision resistant as much as possible.
Okay. That should be collision resistance, right? Like property of the hash function.
Right, so you can view it as this, right? So when you want, for example, if I ask your goals, like irrespective of whether you can achieve or not, you'll tell your goals, right? So I guess in that um, perspective, it's mentioned collision free.
Okay.
So that's the goal, but what can be achieved? So say in the future, like with a, some breakthrough or something, if we are able to achieve collision-free hash functions, right? I mean, I've not read through the papers, but I don't think it's like it's not impossible. It can be achieved. It might be like something is missing. Some, yeah. So
So
you this.
basically, SHA 256 is collision resistance instead of
Right.
collision free.
Right. So currently they are using SHA-256, and you might have so there's like a fun probability um, thing, right? So you might be wondering like there are like so many practical like deployments of these hash functions. For example, in the Bitcoin network and all these things, you basically use hash functions or like variants of these hash functions, and so many inputs are being generated and passed, and so many hash outputs are generated. Isn't it the case that these two will be matching? Like there will be colliding. There will be colliding, but the thing is they won't be having like semantic meaning if arbitrarily like two inputs just collide. And also the probability of two inputs having the same hash like in a random fashion, the
Hmm.
probability of that is significantly lesser compared to a nuclear event occurring in the world. So people should be more worried about a nuclear war compared to worrying about whether two inputs will generate the same hash output.
Okay.
This is like a fun snippet actually. Wanted to share.
Right, sir. So my second question about post-image resistance and second pre-image resistance are the same.
Okay, post image resistance. I have not heard of this term post image.
Actually, sir, it was in that question, but
Oh,
I was confused. I searched for it, couldn't get the answer.
okay. Post image, I'm not sure. Maybe with respect to collision resistant alone, it's guessing, I think.
Yes.
Pre image is the one I mentioned, right? If you do an
Mhm.
inverse of the output, you should not get the input.
Original input. Hmm.
That's pre image. So I guess post image is the collision resistant feature.
Okay. Image resistance. Okay, thank you, sir. That was
Okay.
all.
Good. Thanks, Gaurav. Right. Um, Ganesh Govind, you have raised your hand. You have any queries?
Sir,
Yeah, yes.
sir, can you explain the puzzle-friendly property of the hashing function, sir?
Puzzle friendly property. Okay, so this is with respect to the Bitcoin feature, right? The puzzle function.
Yes, yes, sir.
Okay, so when we tell puzzle friendly, right? Generally, like how will a puzzle be designed? So, for example, you have these that image puzzles, right, with different shapes, and you have to figure out the correct way in which those images have to be placed. So, trying to figure out what the puzzle is, what the correct image is, will definitely take time. So, what are the features of a puzzle? It will take time to solve, right? It should take time to solve, right? Or like only like clever persons or someone who does like significant work to try to solve the puzzle should only be able to solve. So it should take significant time to solve. That is one feature of any puzzle. That's how it should be designed. You cannot just say like the puzzle question is 1 plus 1, what does it means? Everyone will say 2. So it should not be like that. It should be like tricky, as well as it should take time to solve, and it should not be straightforward. That's one feature of the puzzle. The second feature is how do we check whether the answer is correct or not? The answer to the puzzle. So checking the answer to the puzzle should be very quick. So say once you have figured out how to place all the images right in the puzzle, and you get the final image just by looking at the entire finished image puzzle, you will like be looking at a proper image, like say a hero's face or something like that, which you can easily identify and see that it's correct immediately. So say if they have placed it in, say if they have placed like a couple of pieces in a different way, just by looking at the image you will be able to see that it's wrong and they have not solved the puzzle correctly. The shirt button or something will be swapped or something like that just by visually looking at it, right? So basically time to solve the puzzle should be significantly high. They should put in a lot of effort to solve the puzzle, right? So for example, if a person is trying to solve the puzzle, there should be like mentally and physically, like he's spending his time and also his mental mind and everything is putting it in to solve the puzzle. So it takes time to solve and also efforts, right? Not just time, is putting in his efforts. So in that time, say if he had gone and done some other work, he would have earned some money or something like that. But instead, he was sitting and doing this puzzle. So he's putting in a lot of effort apart from just time, right? And the second feature is once he has done the puzzle, it should be very easy for others to verify whether the puzzle solution is correct or not. So this is the basic features of a puzzle. So now, in a blockchain, uh, talking about Bitcoin network, right? So let's not go into the details of Bitcoin because those will be covered in, I guess, week 3 lecture. But just assume a blockchain, right? So basically, a blockchain is nothing but you have, say, multiple nodes n1 n2, nodes as in systems, right? Computers n1 n2 n4 n5 and n6, and say all these nodes are sort of having a common a database, or say we call it as a blockchain, right, in this setting. So they have like a common blockchain, and what they do is every 10 seconds each of the nodes would be proposing a new block to this blockchain to be added to this blockchain, right? So for example, say currently like there's an existing blockchain, so it's present like this. Right, so this is like block 1, 2 and 3, and say node 5 is proposing a new block. It's trying to add a new block to the blockchain, and let's not get into like the details of how it is being added and all these things. Let's just assume that for any node to add a block in the blockchain, it has to solve a puzzle. It has to solve a puzzle to earn its right to add a block in the blockchain. So because if we are not placing any constraint on who is adding a blockchain, right, in this setting, right, so there are implementations where there is no need to solve a puzzle at all. Anyone can just keep on adding blocks to the blockchain. So there are implementations. Let's not go into those details. For now, just assume that to reduce congestion in the network and all those things, right? The node which wants to add a block into its blockchain should solve a puzzle and um, make before adding that block in the blockchain. So for example, if node 5 wants to add block b4 in the blockchain, it should solve a puzzle and it should show to all the other nodes, all the other 5 nodes, that hey, I have solved this puzzle and I'll have the right to add this blockchain b4, block b4 to this blockchain. So node 5 should, one, it should solve the puzzle, and second, prove to others that it has indeed solved the puzzle, right? And the third thing is others should be able to check, should be able to verify that it has solved, right? And over here when we saw the features of a puzzle, right, the time taken to solve the puzzle and the effort taken should be very high. Okay, so this should take a lot of time, and the third step should take very less time compared to step 1, right? And as far as a blockchain is concerned, so now so for humans mental effort and time is like a is a constraint. So using that we can gauge whether they had done the puzzle on their own or like that. But for a system, right, what's the key factor? Like a system is like a non-living entity, but it lives on electricity, right? And some human being is operating that system. And as more and more time it takes to try to solve the puzzle, it's consuming more and more energy, electricity, right? It's not devoting its resources to any other task. So basically that it means the human who's operating the system, right, they are spending financial resources and to buy these electricity and all these things in order to ensure that the system solves the puzzle. So that's the effort that the human is actually putting in to solve this puzzle. So how these puzzles are designed in this blockchain setting is using hash functions, right? So for example, what how it is being done is I'm not going into the details, but say for example I have, node 5 is proposing a block b4, and say it has some contents, it's like a 1 GB file. Okay, so now what the puzzle will look like is it will do a hash, any hash algorithm like SHA-256 or something. It will do a hash of this block, okay, and the output it gets, what the puzzle, the actual puzzle is whatever output you get in this hash function, right, applying this block b4, the output you get should have some set of zeros in it. So for example, out of the 256 bit output, we will say like the first 60 bits should all be 0. So that's the puzzle that the node 5 has to solve. So but you might say like the block b4 is sort of, the input is fixed, right? How will they get a output which is having 60 bits all zeros if the output is something else? So that's where the puzzle actually kicks in. So the node n5 is given the liberty of choosing a value. So basically this is the append function, the append operator. So basically the node 5 will go through like some technique, like a mostly a brute force technique, or randomly it will be searching for some value, some random value to be appended to this block b4, such that hashing both these together will provide an output having 60 bits, the last 60 bits as all zeros. Once it finds a value satisfying this property over here, right, that is the answer to your puzzle. That's the answer to your puzzle. And now
Yes.
one second. Okay, so that's the answer to your puzzle. Now comes the importance of collision resistant and all these things, right? If the hash function is not collision resistant or something, what the attacker can do is if it's not pre-image attack or something, pre-image resistant, what the attacker can do is he can fix an output.
నేను చూసింది గ్రాండ్ ఏమైంది అనుకున్నా కాలేదు.
Just right. So the attacker can fix an output, say some random value followed by all zeros. He knows this B4 input, and the attacker, the node 5 is the attacker now. Instead of doing a brute force approach or like trying to honestly solve the puzzle and putting in lots of effort in terms of electricity and all those things, time and electricity, he can misuse the mathematical properties of the hash function to find a value such that the 60 bits are all zeros, right? So if a hash function is collision resistant, right, up to some extent, the node 5 has no other option than to either try randomly or try in a brute force approach to solve this puzzle. That is, the puzzle is nothing but finding the value such that the 60 bits are all zeros. So this is basically the answer to the puzzle. So the question, the puzzle is 60 bits should be 0 out of the 256 bits, and the answer is find a value appended with this block B4 such that it satisfies this output. Now the node 5 has put in lot of efforts, found this value, found answered this puzzle. Now it should prove to everyone that it has solved this puzzle, and everyone should be able to check. So how will they be able to check? It's nothing but the node 5 will tell to others, this is my B4 value, B4 input, the block B4 I'm proposing, I want to add to the blockchain, and this is the value that I have found, right? This is the puzzle value that I have found, which satisfies the output. Now the other nodes, what they will do is, they won't be doing a brute force approach or anything. What they will do is, they will just simply hash both these things together, and they will just check whether the output they get is satisfying the property that 60 bits are 0 or not. If it's all zeros, that 60 bits are zeros, then it means node 5 is telling the truth and it has indeed solved the puzzle. If not, then node 5 is cheating, and that block B4, whatever node 5 is proposing, right, that will be deleted from the blockchain. That's like an invalid block. So this is basically how the hash function is repurposed to be puzzle friendly. Right? Time to the two features of a puzzle is just repeating, right? You should take a lot of time and effort to solve the puzzle, which a hash function satisfies, because since it's collision resistant, you cannot be able to just like that find the input satisfying some output criteria. Only via brute force or some random luck coincidence or something, you will be able to find the output satisfying that criteria. So you will be wasting a lot of time and resources, and once you have found, others can just do one single hash operation to see whether the output is satisfying that criteria or not. So this is what we mean by puzzle friendly nature of the hash function, and this is how it's being used in the on a blockchain. So is
Yes, sir.
this
I have understood. Yes, sir. I understood.
okay? Cool.
Sir, can you explain why we'll use the nonce in the hash pointer, sir?
Why do we use a
Nonce, NCE.
so yeah, okay, so the puzzle value actually is the nonce actually.
Okay, okay, sir.
So nonce is basically like a random bit. So for example, you're hashing a video file or something, means you don't want, so there are like multiple attacks or like multiple analysis that can be done. So the internals of a hash function is not secret. So one basic rule of say, cryptography and security is, apart from the private key which is to be kept secret, right, the workings of these cryptographic primitives like the hash function or digital signatures like that, they should not be kept secret, because there is always the possibility that there might be a leak of how these um, mathematical functions, the internals of the hash functions work. So the basic principle is, the attacker, we should assume the attacker knows all how the hash function works in and out, right? Should know all the details. But given those details also, the attacker should not be able to find the um, input given the output, or find two inputs matching the same output by misusing the internals of the hash function. So, so basically, and also say for example, I have a hash output. The attacker should not be able to find some relation between the input and the output. Say the attacker should not be able to say that okay, the first 10 bits will be 0, last will be 1, then only this hash output will be coming. So like that also the attacker should not be able to observe, right? So usually, like, to be on a safe side, to increase the confusion that arises, that is to deassociate the input from the output in the reverse way, uh, generally a random value is appended along with your input, and together it is hashed and you get the output. So in this case, in this puzzle, hash puzzle, the puzzle value that you iterate across to find an output which satisfies the criteria, this puzzle value is also a nonce basically. So you randomly try to find a value such that it satisfies the output criteria. So is this clear, Ganesh?
Yes, sir.
Okay, cool. Shriman Narayana, you have raised your hand. Hello, Shriman. Okay, Samiksha, you have raised your hand. Do you have a query, or by mistake you have raised it?
Hello, sir.
Yeah, hello.
Can you explain patterns of hashing data and SHA-256 algorithms?
Okay, so patterns of hashing is, I guess it's explained in the week lectures. So just okay. So hashing, it can be done in any way, right? So there are like multiple patterns. So like, so I usually don't like remember the names of those patterns fully, but basically the way the hash function works is you can provide any input, right, and get the hash output. Okay. So for example, you would have come across this, I guess, sequential hashing. So I am not, I don't know exactly the names of those patterns. I tend to forget those. Sorry, but for example, you have an input, right? And if you say hash this input, you get output one, right? What you can do is you can hash this output also, and get an entirely different output. So basically, this is like double hashing, something like that. Or you can again hash this output also and get a different output, right? So you can do like a sequence of hashing, triple hashing, 4 times, 5 times, n number of times you can keep on doing, and each time it will be giving a hash output. So for the hash function, basically, it doesn't know whether this input, whatever you are giving, is a previous output or not. It just knows it's a random, it's some arbitrary number of bytes, right? And it will just take it, pass it to its hash function, and give a different output, the hash output. And usually, different um, uh, uh, things like the patterns arise, these hashing patterns arise based on the applications. So for example, um, you have a file, right? You have a file, say some document, and you have done a hash of this document, and it is say point, it is output 1, right? Now you want to say append a page to this document. So you can either hash the entire file again, that will say provide output 2, or what you can do is, I know the hash of this page 1, that is op1, output 1, and what I can do is I can just hash this part alone, which will provide output 3, and along with this I can hash both these together, to get my final output, right? So depending on your input size, right? So if it's a very large file or something, usually then your time taken for the hash function to complete will increase, right? So instead of doing repeating it for the whole file again and again, say now instead of just adding one page, and keep on adding like one page after another every day, then each day will you be hashing the entire file again and again. So instead of doing that, what you can do is, for each page you will be having a hash output, and you can just use those hash outputs, append those together or hash those together, and find it. So one another way to look at it is, say you have 100 pages, you'll keep on adding pages, right? You can either have hash outputs for each of those pages, so output 1 to output 100, or you can hash the entire outputs together and just get one 256-bit output, right? So it basically depends on the application and how much storage you have, how much computation you have. But irrespective of it, whether you do one time hash or two times hash or 100 times hash, the collision resistant property should be the same. That's the key property. So this feature, like these patterns of hashing, it all um, deals with how much storage you have, how efficient you want to do these hashing, how much time you want to spend in this hashing algorithm, those aspects. So that's how these patterns of hashing emerges usually. As far as the blockchain course is concerned, um, there will be like two patterns of hashing that we'll be looking into this. So one is like in the blockchain, right? So a primitive blockchain is, say, you're keeping on adding blocks, and you want to ensure that the fact that, say, someone should not be able to tamper with the blockchain. So basically, you just see the blockchain as a linked list, right? So linked list as in, so this is the start of the list and this is the end of the list. So I assume everyone like, so linked list is basically like, um, you have an element, and that element will point to the next element. Basically it will have the address where the next element is present. That's basically a linked list. And so a blockchain is basically a linked list, but what it has is, instead of just pointing to where the previous block is present or what are the contents in it, it will contain a hash of the previous block. And this is basically what they call it as the hash pointer. So this terminology arises from the linked list. So instead of just having a pointer to the next block or the previous block, it will have the hash of that previous block within its own block. And how this hash is being used is, when you are solving the puzzle, right? So when I mentioned I'm solving a puzzle B4 and I'm finding a value such that the output is satisfied, output constraint, along with the input, along with the B4 block, the new block that has to be added, and the value, the puzzle value which I have to, the node has to solve, it will also be having as part of the input the previous hash of the block. So every block, whenever it gets added, it will take the hash of the previous block, right? It will take the entire hash of this previous block and append it along with its block, whatever it has to be added to the blockchain, and solve the puzzle and add it to the blockchain. Now the advantage of linking these blocks via these hash values of the previous block is, say someone is tampering with block 1, they will be changing the hash value of this block. So when someone does hash of block 1, it will lead to a different value itself. It will lead to output 1 dash, right? Now say a third party member or someone is trying to audit the blockchain and they want to check whether the blockchain in Sol is legal or not. How they will check its legality is whether the puzzle is solved properly and whether it's solved properly or not. So now what they will do is, they will see the hash of block 1, it should be some value, and they will input that value to this block 2 hash along with that puzzle value and see. And since the hash function is designed in such a way that even if I change one bit in the input, it will lead to a different output itself, right? So if someone has tampered with block 1, the hash of block 1 will be different, and when I try to use that hash in the hash of block 2, right? So here if it's block 2, then it will lead to a different hash itself, and it might be the case that the output constraint will not be satisfied. And people can easily figure out that someone has tampered with the blockchain. So this is the use of hash pointers in proving the integrity of the blockchain, right? So this is one pattern of a common pattern of hashing, which is relevant to this blockchain course. The other important aspect, the pattern of hashing, is what we called as hierarchical hashing. So in later uh, in the next lecture or something, like you will be so there is a term called Merkle tree or Merkle proofs. So we will be discussing about this hierarchical hashing in when we discuss about uh, Bitcoin transactions and those things. So in Bitcoin transactions, basically they have this hierarchical hashing. So Samiksha, is this query cleared, or do you have any other query?
Okay, thank you, sir.
Yeah, thank you. Uh, One second, Sriram, Shriman. Okay, Shriman, do you have a query? If you have, you can post it in a chat box. Okay. So till then, so Gauri, you have raised your hand. Do you have any queries?
Hello.
Yeah. Hello, Gauri.
Yes, sir. In the class, it has been mentioned that blockchain is not a distributive database. So, can you please explain about that?
Right. So that's like a. I'll just mute. I've just muted you to avoid the feedback noise. So the question is like, what's the difference between a distributed database and a blockchain? So the basic thing is like you're sort of comparing apples and oranges. So first of all, you should understand what they want to achieve in these distributed database versus blockchain. Just a second. Right. So, for example, if you take a normal database, it should be available all the time. This I'm telling for a normal database, right? A normal database, it should be available all the time, and it should be it has some features, right? Data should not be corrupted, and all those things. A distributed database is where um, say you have like a Google type of infrastructure, or even like a small MNC, you will have servers in multiple locations, and each server will be proximally close to a set of clients. Say, for example, European clients will be accessing, they'll have like faster access to the servers present in nearby the European continent, right? So the idea of distributed database is one step ahead of one step um above these normal databases, where you have multiple copies of the database, and the goal is now to ensure that there'll be like multiple people working on these databases. For example, you will have say one database in India, one in USA, and one in Germany, right? And everyone are part of the same, say, company, Google or something, or like um, like Google or something. So one employee will be accessing so uh, the thing is like the values present across all these databases, the content will be the same. But say some employee is changing some value in the database and it gets first reflected in the Indian database. Now in a distributed database, the main thing it has to worry about is, say some other person in US updates the database and it changes the value to, say for example, it changes x equal to 1, here it changes y equal to 2, here it changes z equal to 3, right? So like different users change different values at different instance of time. Now the main goal of the distributed database, the feature is to ensure that after some time, all these databases should sync up and should have the same contents. So this x equal to 1 should be propagated to these two databases. This y equal to 2 should be propagated to the Indian and German databases, like that. So the main feature of distributed database is to ensure the data is available, as well as since you have multiple copies, even if one database is down, you don't have to stop your entire system does not crash, because there are other databases which can service your request. But for it to service your request, you should always ensure that all the databases are having the same value always, and that is not possible. Say like say one user is updating some value in the Indian database, you cannot tell the other users to stop using the database for that particular period of time, right? Until this value gets propagated to all the other databases across the world. You cannot place such a constraint. So a distributed database should not stop the users during that period of time, but it should sort of like sync up periodically, or it has like internal protocols on its own to ensure that it finally arrives in a synchronized state. So whatever updates an Indian user does should reflect on all the other countries' databases also. Right. So this is the goal of the distributed database. And here you should understand the setting in which I'm discussing this distributed database. So it's basically for example, a company or something like that, right? So Google has its own distributed database infrastructure, or Amazon has its own, or you can rent out these infrastructures from like AWS or something. So it's sort of like a company-wise centralized way. A blockchain, if you come to blockchain, the goal of blockchain is entirely different. What it tries to achieve is something called as trust, right? And trust in the sense of decentralization. So that's the core idea of blockchain, how it came into being. It should not, the essence of blockchain is there is no single owner or no single company which controls all the databases. So a blockchain is also, you can think it as like a distributed database, multiple nodes trying to having its own database and trying to sync up with each other, right? That's basically what the blockchain does. But there is no single owner of this distributed database like Google or Amazon. Every node in that network, right, which is maintained part of this blockchain, is a leader on their own, is a like owner on its own, and they have like equal stakes in the blockchain. So if everyone like tries to be corrupt, right, in the blockchain, then no one will trust that blockchain, and basically that blockchain will have no use. So that's what they try to bring out in blockchain. It's all about like trust and decentralization. So even without a centralized power, a centralized organization maintaining this distributed database, how will you ensure the integrity of the data which is present on these databases? So in the first case, say like if you are working in a company or something, excuse me. So if something wrong happens with, if some database gets corrupted or some attack happens, Google as an organization will take blame, and it will do some remedial measures and try to recover the data or something. But in a blockchain, especially in decentralization, you won't be knowing who the other user is the other participants who are trying to add blocks to the blockchain. It can be anyone with just a laptop and internet connection. From Ukraine to Afghanistan to Singapore, anyone can try to add a block to the blockchain. How will you ensure that they are not tampering with the blockchain and they are trying to be honest while adding blocks to this blockchain, right? They don't tamper or they don't act maliciously. So how will you ensure that using these hash puzzles and all those things, you sort of ensure that no one is able to tamper with this blockchain, and in turn what happens is the users of the blockchain are able to trust that the blockchain is not tampered with, and they have a trust that the information is secure, and secure as in like it's not private, but the integrity of the data present on the blockchain is intact. So that's the entire goal of the blockchain. So it is a distributed database, if in my opinion, right? So all the concepts that you learn in distributed database will apply to blockchains also. It's sort of a mix of distributed database along with these cryptographic primitives in a fancy, like an interesting way, mixed together such that we achieve this trust and trust in a decentralized manner. So that's what blockchain is all about. So does this answer your query, Gauri?
Yes, sir. Thank you.
Okay, thanks, Gauri. Deblina Chowdhury, you have raised your hand. Do you have any query?
Yes, sir.
Yeah.
So I have question in repeated hashing. So in repeated hashing, after generating the first 8 hexadecimal digit for hello world, why are we again generating the 8 hexadecimal digit using the first one? What is the difference between the first and the second digits?
So you mean like they are providing hash of hello world and say it results in output 1, and they
Yes,
are
sir.
providing this output 1 again and generating output 2. This is
Yes,
what
sir.
you mean, like. So what's your question? What's the difference? Why can't they just stop at output 1? Is it?
Yes, sir.
Right. Just so they so as I mentioned, right? It just makes life difficult for the attacker to try to find any association between the output and the input. So uh, it's just like the hash function is collision resistant. There should be no doubt about that. It should be collision resistant up to some level. But why they do repeated hashing is so in this case, um, one possible answer is they don't to enhance the security, or like as I mentioned, like to make life difficult for the attacker. They just do a repeated hashing and arrive at another set of like a hash output. So for example, if the attacker he gets hold of this hash output, right? So this will be the one that is stored in the database. Okay. So for example, instead of hello world, let's make it interesting, like you're having a password, right? And I'm storing the thing as repeated hashing, so I'm doing like a double hash, and I'm storing the final output in a database. Now if the attacker is able to get hold of this database contents, he will try to somehow do like a pre-image attack or something, where given this output he will try to find the input. Now, without say this repeated hashing, say if the hypothetically attacker has like so much of computational resources, like God-given computational powers, right, which no one has on the world, and like he still has, like in that case he'll be able to anyway find the input, but let's assume he has some limit to that. So he has to do sort of like a double pre-image attack, right? So basically he should find first, from starting from output 2, he should find output 1, and then he should find the actual password. So it basically complicates the attacker's job in trying to find the input which led to this output, because now you have an output 1 in between, right, which is again hashed to get the final hash output. So you can, in this repeated hashing, you can do it like 5 times also or 10 times also, and each time when you do it, it sort of complicates the attacker's job in finding this proper input. So he cannot just directly using output 2, he cannot just directly find out password. He should go via all these steps actually.
Okay, sir. Understood.
Right. Okay. Thanks, Deblina. Mahendra, you have raised your hand.
Yeah, I had a question on that, which you're talking of that blockchain synchronization. So when, say for example, node 5 adds a block to the blockchain, so how does it get, how do others kind of validate it? It gets synchronized to all their systems, or, I mean, because there's a new blockchain which is in the node 5 now.
Right. So I guess your question is, say when node 5 adds a block, how do all the other systems get to know of this?
Yes, I mean, how will they get the updated
Right, right.
blockchain?
Yeah, I get it. So if we have 6 nodes like this, the when we tell a blockchain, we just tell it's like shared among all these things. But in reality, what happens is each of these 6 nodes will be having its own private copy of the blockchain. Okay. And now what happens is, and there will be like a network. They will all be connected via a network. So for example, node once, so each node will be having its own IP address, and say node 1 knows the IP address of node 4 and node 2, so it's connected. Node 2 knows the IP address of node 3 and node 5, right? Node 4 knows node 5, node 5 knows node 6, okay, and node 3 knows, just keep it like this, okay. Node 3 doesn't know node 6, just keep it like this. So now what happens is, when let's assume like 3 blocks are added to the blockchain, and every node has its copy of the blockchain. So there is nothing like a central shared uh, blockchain copy that all the nodes work on. That's just for like representation purpose, but the internal working is, the overview is as is. Um, so every node will be having like a private copy of the blockchain, and say node 5 is proposing a block B4, and it has solved the puzzle value and all those stuff. Now what node 5 will do is it will propagate this block B4 along with the puzzle value to all the other nodes that it is connected to. So from node 5, it will send the B4 this message. Say this is the message it wants to send. The block B4 it wants to add and the puzzle value. It sends this message. Node 5 sends it to node 2 and node 4, node 6. To all those it is connected, right? This and this. Now node 2, node 4 and node 6, it will see it has received a new message, and it will propagate to its neighbor nodes. So node 2 will send it to node 3, node 1. Node 4 will send it to, sorry, node 4 will send it to node 1. Node 6 does not have any neighbors. Node 3 has only node 2 as its neighbor. So basically, the block B4, whatever it originates from node 5, it's sort of propagated throughout the entire network. And every node, right, every node, irrespective of who sent it or how it received it, right, every node will ensure this puzzle value is correct or not, right, that output constraint, it should be satisfied. And if it's satisfied, if that node uh, verifies it's correct, then node 1 will add this block B4, node 2 will add block B4, node 3 will add block B4. Similarly, node 6, node 5 would have added already, and node 4. So every node will receive a copy of this block B4 via from N5 or any of its neighbors along with the puzzle value, and they will update their own blockchain. So it's not having like a centralized blockchain copy on which every node works. It's this synchronization happens via this network propagation mechanism and all these things. And that's the interesting aspect of blockchain, is because it's the sort of like you're having an application of cryptographic primitives like hash function and in these puzzle values, and just having these puzzle values won't make your blockchain efficient. You should be able to try to sort of find out a, a protocol or network protocol where in minimum amount of time node 5 is able to communicate to all the other nodes in the network that it wants to add this block before having this puzzle value. So and also the number of uh, messages that are being sent across the network should be kept to a low. So you cannot have a network say node 1 is connected to all the other nodes, node 2 is again connected to all the other nodes, like that. So that will complicate the situation. And here I am just mentioning node 5 is proposing a block B4, but assume that to complicate things, right, you want node 6 can also propose say another block, so B4 dash, right? It can propose another block having a different puzzle value for so before node 5's message reaches node 6, it would have node 6 would have sent out, hey, I want to propose a block B4 dash having this puzzle value. So all these complications might occur, but finally after some time every node should either decide on whether B4 will have is to be added or B4 prime is to be added. And finally, either one of these blocks would only be added, because if you look at the blockchain, right, so 3 blocks are already there. Node 5 is proposing a block B4 which is having a hash pointer, right? It's pointing to this blockchain which is B4 uh, by node 5, and the same position in the block in the blockchain. Node 6 is proposing a different block B4 prime having a different puzzle value, right? It cannot be the case that you cannot just add B4 followed by B4 prime, because the hash pointer concept that we discussed, right, the hash of the previous block, that will not be no, that will be wrong. It will lead to a wrong computation. So either of these 2 blocks alone can be inserted in this position, in the 4th position in the blockchain. So this is how usually Bitcoin works, right? And this is how the messages and the blocks are transmitted across the network.
Yeah. Thanks a lot, sir. Just had this thing that if some people collude and all of them decide to add the wrong block, I mean, does that happen? Does that possibility happen?
Right. So in Bitcoin, right, Bitcoin uses this hash puzzle, right? It uses this hash puzzle, and a key feature of this puzzle is why is it a puzzle? Why is it difficult? Is they should do brute force or some random approach by luck, and it leads to electricity usage and so much of financial so much of money has to be spent to run those missions. And in return, what do they get as users is the one who solves the puzzle, who adds the block, will be getting some rewards, right? In Bitcoin terminology, those are like Bitcoin rewards they will be getting, and for the effort they have put in. And now the assumption in Bitcoin is 51 percentage or more should be honest. Now 51 percentage of users it does not mention. What it mentions is 51 percentage of the entire computational power. So it does not mention say like there are 100 nodes. It doesn't mention like 51 nodes should be honest. instead it mentions 51% of the entire computational power should be honest. So it can be the case like 100 nodes are there, N1, N2, N3, and then 100 nodes. But say uh, computational power as in number of hashes it can search per second. So say like it does like a brute force, right? To solve this puzzle, it goes through all the possible values to find the proper output satisfying that constraint. So usually computational power with respect to hash puzzle is specified in hash rate, number of hashes it can search in a second, like that. So say like nodes N1 and N2 put together, they have like 1000 hash rate, and nodes 3 to 100 have just 50 hash rate. Then what happens is two nodes, right, have majority of the computational power in their hand, and if these two nodes act maliciously, so by acting maliciously, what it means is what they can do is, if say all the other nodes, node 3 to 100, they are having a block chain like say B1, B2, B3, and each pointing to the previous via these hash pointers, and they have solved the puzzle, right? Now nodes 1 and 2 with their superior hash power and all those things, what they can do is they can start a new blockchain itself and convince the others that this is the correct blockchain. So they can start like a new blockchain B1 prime, B2 prime, B3 prime, B4 prime, like that, with the proper puzzle values, everything properly set in. They would have done it the proper way, the brute force way itself, to find the puzzle value and to solve all these things. But since they are having so much of computational power compared to the other nodes, the time required for them would be very less relative to others, right? Say the other nodes take like 5 days or something, they will just take 4 hours or something to find a node, sorry, find a block and add it to the blockchain. So basically then what happens is you will be able to rewrite your entire blockchain, and you can that's sort of the core feature of a blockchain is it should be append only, right? But that is um, uh, that is falsified in this aspect, right? When two nodes are able to control your entire blockchain, if they are malicious, then your entire blockchain wreaks havoc, right? It cannot be trusted at all then. So that's why Bitcoin has this concept assumption that 51% of the computational power should be honest, and if they act maliciously, then the blockchain cannot be trusted with. So in recent times, so when we discuss Bitcoin, we'll be discussing about something called as mining pools, right? So remind me that we'll discuss about mining pools and how it um, conflicts with this Bitcoin's assumption of honesty.
Okay. Thanks a lot.
Yeah, thanks, Mahendra. Okay, Shriman has posted this question. Is there a limit on the length of the nonce value? No. So a nonce basically is a 250. So usually they set the nonce is basically a random value. So it can be of any size, but some algorithms specify the nonce to be of some particular size just to be uniform in implementation. And what if there is no solution to puzzle even after trying all possible nonce values? Good question. So the property of the block, the hash function, right? If the previous couple of slides back, right, we have mentioned that the hash function input is of any size, but the output will be very small, which is 2 power 256, assuming SHA 256. So here assume it is say 512 bits. Okay, so then all possible inputs is 2 power 512. All possible outputs is 2 power 256. There is no way that you won't be able to find a puzzle value after searching through all the 2 power 512 possible input values. Because intuitively, right, your input size, the input domain is significantly larger than your output range. So definitely, so if you cannot have a one-to-one function over here, you cannot design a one-to-one function. So there will always be like multiple value to one function, right? So it's not possible for to design a one-to-one function. That's not what hash functions are. So you will be able to find a value. On average, after crossing like the halfway limit, you should be able to find a value. So does that answer your question, Shriman? Okay, cool. Gokul Nath has asked, is there any prerequisite to learn blockchain? Okay, a good question. So so I'll tell as far as this course is concerned. So as far as this course is concerned, it's offered under the CS domain with the course ID CS15. So it will contain computing terms. We'll be looking at the applications of blockchain, and then examples of some cryptocurrencies, and then blockchain platforms beyond cryptocurrencies, right? And then we'll be looking at the underlying protocols of these blockchain platforms, basically the consensus protocols, right? And other things. So these will be, and also some security features of uh, technical security properties of these blockchain attacks, security attacks on the blockchain. Okay, so this is the agenda of how this course is designed, since it's offered under the CS domain, computer science domain. But if you are if you are not a CS domain, it will be slightly difficult to follow the course, the rest of the course lectures. But it's not the case that you're fully alienated from blockchain. That's not the case, because a blockchain is sort of a mix of, in my opinion, like economics and then CS concepts. You have game theory concepts and all these things. So it's not like only CS students should be learning blockchain. It's not like that. So take the example of Bitcoin and all these things, like practical applications of a blockchain. Now, who uh, uh, sets the prices of these Bitcoin? There is like so much fluctuations in these Bitcoin prices and all these things. So basically that's where game theorists and economists come into the picture, right? Just having like a CS background will not help to design a proper blockchain application, as in like from a cryptocurrency perspective. So having a financial background and all these things will really help in these cryptocurrencies and blockchains. So in cryptocurrencies, there is like decentralized finance and all these things. So basically, if you take normal finance, you will have a bank, you will have the customer, and you will be taking loan from the bank, you will be depositing some money like that, or you will be buying some bond, gold bond or property bond like that. Decentralized finance is trying to replicate whatever the bank is doing, but instead of the bank being the centralized entity in the traditional way, they want it to be decentralized and put everything on the blockchain, right? So that is basically decentralized finance. And um, so there are like multiple avenues for non-CS students, non-CS folks to get a head start into blockchain. And so for non-CS folks, right, uh, like there are multiple ways in which they can contribute to blockchain. One is this cryptocurrency techniques and all these things. The other is like token economy. Right? So we'll discuss about this token economy later. So all these things are sort of like non-CS things, which will be easy for the adult folks to quickly grasp and get going. But as far as this course is concerned, if you are taking it seriously, you should have some bit of CS background. But if you put in like effort to Google the concepts which you don't understand, or ask in the discussion forum or in the live sessions, and if you are able to get an overview of those concepts, then you can get good grades in this course, even if you are non CS background, because the assignment questions won't be that difficult. They won't be asking you to implement something or practically or something like that. It will just be based on these high level ideas and all these things. So if you follow the course contents and come across a new term, and if you just Google that and or ask in a live session and try to understand the high level overview, that will be good enough for you. So does that answer your question, Gokul? Okay. So Gaurav Mishra, you have raised your hand. You have any query?
Yes, sir. About the prerequisites, there were four topics: computer networks, operating systems, cryptography, and network security. So, do I have to deep dive into the topics? I am from non-IT background, sir.
You are from a?
Non-IT background, like,
No, you need not deep dive into any of these things. So as and when you come across a new term, right,
yeah.
you just Google it out, because many of these terms intuitively itself you will be able to get a meaning. So if I tell synchronous networking or asynchronous networking, which is like a one-line explanation, we'll be able to get the intuitive meaning behind what these terms really mean, and
Okay.
you won't be requiring so much of. You need not deep dive into these concepts. So even for me, if you ask, like, I don't know like in its entirety cryptography or networks, right? But the high level overview I know, like the
Okay.
hash function, these should be the properties, one way, collision resistant, and all those things. So if you ask me the internals of a hash function and all those things, I am not a cryptanalyst, so I don't know all these details. So there are books for all those things, but as far as this course is concerned, by prerequisite, what I feel they want to express to you guys is that they will be touching upon the terms related to these fields, and you should be open to getting to know these terms, and you should sort of like put in some effort to find out the meaning behind these terms. So that's all what is expected from you.
So, will there be any coding part in
No,
this?
none of the NPTEL, like some courses have a coding part, but in this
Okay.
course there is no coding part.
Okay. Thank you, sir.
Okay, I have some messages posted. Okay, Divya Ravindran, she has posted. So, is the scalability of a blockchain measured based on network interaction speed to networks like N1 to N6 interaction? Yes, how fast your blockchain is. So, the scalability of your blockchain is in like two. So, as and when the number of nodes increases, right? Uh, so basically, when you mention the scalability of the blockchain, um, um, yes, it sort of it's tied down to like various aspects. One aspect is this network interaction speed too. Obviously, you cannot control the network speed, right? You cannot like having a 4G connection. You cannot expect 5G speed. That's not possible. Uh, but what is in your hands as a blockchain developer or designer is how to minimize the number of messages being sent, and how fast the nodes in a blockchain can arrive at a consensus. That is, how fast they can be synchronized such that whether to add this block to the blockchain or not. to arrive at a common decision. That's what we mean by consensus among all the nodes. So how fast they arrive at a decision affects the scalability of a blockchain. So for example, if as and when the number of nodes keep on increasing in a blockchain, the number of messages we have to send to the other nodes, time to stay sync or reach consensus will also increase. And if you had designed your protocol in such a way that it results in lot of messages being sent, duplicate messages being sent between different nodes, and leads to a lot of confusion and all those stuff, then it will definitely affect the scalability of your blockchain. So does that answer your question, Divya?
Yes, sir. Thank you.
Okay, cool. Sanidia Kumar has asked, sir, how to calculate the number of hash operations in SHA-256 required for matching two outputs? Okay, so there is like some particular like a probability based formula for those. Specifically for that weakly collision resistance I mentioned right over here. Let me just right. So, like collision resistance, there are two types, right? Weak and strong. So, if you the input is known, the output is known, and you have to find another input, then on average they have to go through some, like say if it's 2 power 256, SHA-256 means they should go through like 2 power 255 number of iterations on average to find another input which matches the same output. To achieve strong collision resistance, that is to find any two inputs, there is no constraint on the input, the attacker can find any two inputs but having the same output. Then in that case they can do sort of like a binary traversal, like on average for a SHA-256 algorithm it will be like 2 power 128 iterations like that. So the number of iterations, so in your question it's not like number of iterations, right? Hash operations as in iterations required depends on the output size of the SHA-256. So that's why basically, so if you look at nowadays systems in your network browsing or browsers and all these things, I guess they will be using SHA-512. So if you increase the output range, the number of iterations required to find these collision inputs via brute force approach will also increase um, exponentially, and it will be time consuming. So the hash output plays a significant role in calculating this number of hash operations. So does this answer your question, Sanidia?
Yes, sir. Yes, sir. Got it, sir. Thank you so
Okay,
much.
good. So Mahesh Kumar has asked a question. Will there be any programming assignments? Okay, there won't be any programming assignments, but we will be, there will be like a uh, within the lecture they will be showing a sample program on the Ethereum blockchain. It will be like easy to follow. Um, Programming language, whether it's a prerequisite or so, there won't be any programming assignment. Programming language you need not learn, but from a general taking it as a general question, right? If you want to get involved in a blockchain project or something, what languages you should learn? There are like multiple blockchains, and you will based on the blockchain that you select. For example, if you want to code on Ethereum, right? Um, there are like multiple languages that support the Ethereum platform. There's like Solidity and all those things. So one advice to you all is do not see like it's using this language and I don't know this language and it impedes the adoption of the blockchain. You should not view it as view it like that. You see it like what are the properties of the blockchain and all those stuff. So that should be the main deciding factor. The programming language is sort of if you know say Python or C or any other language, It should be good enough because it's the same concept of variables, functions, and all those things, just wrapped in a different way. The syntax will vary, but the reasoning and the semantics will always be the same between any two languages. So it will be easy for you to pick up a new language too, right? So don't be constrained by that aspect. And so does that answer your question, Mahesh? Okay, I take it as an yes then. Uh, Kiran has asked a question. Okay, thanks, Mahesh. Kiran has asked a question. Is it possible to get the recording? Yeah, all the recordings will be posted on YouTube on an Excel sheet. The YouTube links and the sheet will be shared to you, possibly in within the next. You just expect a couple of a day delay of day or two because the video should be uploaded. Maximum a day delay. That's all. So the recordings, yes, this session is being recorded. So okay, thank you, Kiran. So any other doubts anyone else has asked? Okay. So in that case, if no one else has any other queries, it's 7:50. Then I guess we can wrap up the session. Okay. Cool. So thank you everyone. Thank you so much for attending and making the first session very interactive. Hope to see all of you guys, all all the learners to get your doubts and join the next week's live session too. Yeah, Gaurav, you have raised your hand.
Yes, sir. My last question is UTXO a property or a function of hash? It was in the question.
UTXO.
Yeah.
Oh, it's in the question, so I cannot answer the question directly. So
Yes, sir. Can you give hint like what should I
no,
search?
that's assignment question, right? I should not
Yeah.
answer.
Okay. Thank you, sir.
Right. Uh, Anyone else has raised your hands? I saw like a couple of hands going and coming. Yeah, Sridhar, you have raised your hand. Sridhar, do you have any query? Thanks, Mohan. Thanks, Dinesh. Thanks, Divya. Thanks, Parvati. Thank you. Thanks, Anidia. Thank you. Thank you, Shriman. Anyone else has any question? If not, we can end this session. Yeah, thank you all. Thank you. Hope to see you all in the next week's live session. No, I won't be active on LinkedIn, so so Sujal, I suggest you post your queries on the forum. Uh, I will go through those queries and answer it in the live session, the discussion forum. Sakshi, you have raised your hand. Do you have any question?
सर कैन यू प्लीज टेल मी एग्जाम हमारा किस टाइप का होगा?
Exam will you will be probably going to a NPTEL center, the TCS Ion, I guess so. One of those centers, and you will be attending the exam. Online exam, but from test center like that.
एंड सर जो असाइनमेंट्स हमारे वो सारे एमसीक्यू बेस्ड रहेंगे?
Right, everything is MCQ based. Mostly it will be MCQ based only. So the general trend is how the assignment questions are the same way only your final exam questions will also be more or less. If there are any changes, we'll announce it in the forum.
एंड सर असाइनमेंट 0 के मार्क्स भी हमारे इंक्लूड होंगे?
No, assignment 0 marks are not included. It's just a practice assignment.
अच्छा, और ये जो असाइनमेंट के जो क्वेश्चंस है उन्हीं बेस पर एंड का एग्जाम होगा?
Wait, I didn't understand the last one. Can you repeat?
जो हमें असाइनमेंट में जो क्वेश्चंस मिल रहे हैं वही क्वेश्चंस हमारे एंड एग्जाम में आएंगे?
So that will vary. So some questions might come, some will be new questions. So you should not expect, say, 12 weeks are there. Each week, 10 questions. So 120 questions you will be having. So in that case, you cannot just expect same 120 questions to repeat in the NSEM. Some questions will be new also. So you should go through your lecture, answer the assignment questions, finish off, and attend the NSEM with the concepts that you have learned. Some questions, like 5 questions, might be repeated, or a flavor of that might be repeated. Say, instead of asking true or false, they will ask like a MCQ something else. But the concepts will be the same. Stick to your lecture. That's it.
सर एंड सेम में टोटल कितने क्वेश्चंस आएंगे?
No, that I don't know. That it varies. That the professor setting the question paper, they will decide. But mostly it will be for 100 marks or like I guess 2 or 3 hours exam. So it will vary. So at that time, like in the 11th week or something, after a month or so, you will get to know after 2 months.
और सर ये एग्जाम ओनली एक दिन में होगा या ज्यादा टाइम लगेगा?
I'm not sure. So mostly what it will, either it will happen like 2 batches or just 1 batch. So usually NPTEL exam means it will happen like Sundays or like Saturday, Sunday, usually Sunday morning 9 to 12, and then evening 2 to 5. Uh, Blockchain will be either in morning or evening or in both slot. It depends. Just one slot, I guess. The timing, exam center, everything. Once you enroll for the exam, they will tell you.
ओके सर, थैंक यू सो मच.
Yeah, thank you. Thanks, Lavanya. Thanks, Mahesh. Thanks, Karunya. Thanks, Ganguly. Thank you all. If there are no other questions, then we'll end this session. Thank you so much, everyone. Hope to see you next week. Do come with all your doubts, and let's have an interactive session again. Thank you all.
Sir,
Yeah?
थैंक यू सर.
சார் அசைன்மெண்ட்லாம் எப்படி சார்?
Assignment interactive, Ganguly. Sorry, MCQ text. You should answer the assignments.
ஓகே சார்.
Okay.
ஓகே, ரொம்ப தேங்க்ஸ் சார். தேங்க்யூ ஸோ மச்.
Thanks, Ganguly. Okay, then. See you all. I am ending the call. See you next Saturday, same time, 6 to 8, same meeting link.